Alright guys, so in chapter 3, we're going to start looking at some more algebraic expressions. Now, why don't you just look at this picture I have up here with envelopes and chips. And the way I described it, I said, well, you have 3 envelopes and then 5 chips and then 4 envelopes and then 3 chips. But is there a simpler way of describing what we have? I'm hoping that you'll agree that we have 1, 2, 3, 4, 5, 6, 7 envelopes. And 1, 2, 3, 4, 5, 6, 7, 8 chips. If you can understand that, then you should be able to understand what we're going to be doing with algebra. Because what we're going to do is we're just going to be combining, rather than envelopes and chips, x's and y's. So let's look at this first expression. This really says we have 3 x's and then 2 x's. How many x's do we have altogether? 5 of them. It's as simple as that. Okay? Let's try this one. Now, remember your PEMDAS. We're going to go from left to right. So let's look at this expression. We have 2 x's and then 4 x's. Well, that gives me 6 of them. And then I'm going to take away 9 of them. Now, I know how to add these because this is just adding sign numbers. 6 x's goes in a positive direction. Take away 9, positive 9, that goes in that direction. I know I'm going to subtract. 9 minus 6 is 3 x's, but I keep the negative because that 9's bigger and it's going to the left. So that means it's going to be negative. Alright, let's check out this one. 5 x's plus 6, well, I can't combine those. Plus another x, oh, I can combine that. I have 5x, and there's a 1 understood to be there, and a 1x. 5 and 1x, that gives me 6 of them. And this plus 6 just kind of hangs out. I can't combine it with the x's because there's not an x with it. Okay, so let's do this one. 3x, I'm searching. Do I have another x I can mess with that? Right there. 3x plus another x, that's going to give me 4 of them. Now let's look at this. Minus 4, okay. If I take away a positive 4, that arrow is going to shoot me in that direction. Minus 2, that's going to shoot me in that direction. It's like saying this. Minus 4 minus 2. Negative 4 minus 2. It's the same concept. So, I know if the arrows are the same, I add them and keep the sign of the left. So, you can write it as plus negative 6 or 4x. If I'm adding negative 6, that means I'm going to the left. It's the same way as taking away a positive 6. So we're going to talk about this more in class, but either way you want to write it is absolutely fine with me. And we come across that in a couple more of the problems. Now, in order to do these problems up at the top, you've got to remember your distributive property. And we did this way back in chapter 1, where if we have a number that's being multiplied by sum or difference, you're allowed to distribute that number to each of those addends. So let's apply it down here. So instead of 3 times x plus 4, we can rewrite it as 3 times x plus 3 times 4. But we know what 3 times 4 is. That's just 12. And that is considered simplified. We got rid of the parentheses, and then we combined the 3 and the 4. Now, let's look at this one. It's the same concept. Negative 2 times 5x. I'm going to bring down that plus. Negative 2 times 3. Negative 2 times 5, I can do that. That's negative 10. Plus, negative 2 times 3, negative 6. You can leave it like that, but it's the same thing that we just did. If we're adding negatives, that's going in the left direction. You might also want to write it like this. Either or is perfect with me. It's the same concept. We're going to the left in both cases. Now, just as before, there's a little 1 there that we can't see. It's called 1 understood. Let's go ahead and distribute that negative 1. I'm going to bring down my plus. Negative 1 times 1. There we go. Easy, right? Negative 1 times 7 is negative 7x plus negative 1 times 1, that's negative 1. You can leave it like that, or like we mentioned up here, adding a negative is taking away positives, right? It's the same thing. Either way, I do not care how you write these. They're the same. Okay, let's do this one. So negative 1 times 4x. I'm going to bring down my negative. Then negative 1 times 6. Okay, negative 1 times 4, it's a negative 4x minus negative 1 times 6 is negative 6. Now, you can leave it like this, but I think there's a better way to write it. When we take away negatives, remember I said if we take away negative things in my life, that makes me happy, that makes me want to go into the positive direction. So I think a better way to think about taking away negatives is adding positives. It just looks a little simpler. It looks a little easier on the eyes, I think. Now, the ones that we did up here are very different than these. Do you see there's not an addition or a subtraction in there? It's not a sum or difference what's inside that parentheses. Everything that's going on here is multiplication. Now, we remember back from chapter 1 that multiplication is associative. So I'm allowed to switch around those parentheses. And it's just a little bit easier to see what 2 times 3 is this way. And that expression simplified is just 6x. You don't have to do this. I'm sure that some of you will just see it, right? I'm allowed to switch the parentheses because it's associative. And then you'll see it's negative 18x. I'm just kind of showing you the justification why you're allowed to just multiply the negative 3 times the 6. Okay? Yeah, now we're just simplifying. I bet you can see that distribution that's kind of embedded in the middle of that problem. So I'm going to distribute it just to the x and the 2. Okay? So 5 times x plus 3 times x plus 3 times 2 is 6 plus 7. So let's combine our like terms. So 5x plus 3x, that gives us our 8x. And then I can combine those as well. That's 13. Alright, so I'm telling you now, this one is a tough problem. It's not easy. We are going to go over this one in class. But I want to show it to you now, so it's not the first time you've seen it. Okay? So I can see that I can distribute. So 4 times x plus 4 times 3. Now you have a choice here. This is a positive 4 that we distributed. Do you see that you can think of this subtraction as a negative 5? And we'll talk about that in class. But I'm going to go ahead and I'm going to distribute that. I'm going to say, okay, it's plus negative 5 times 3x. Bring down that minus sign. And then negative 5 times 2. See, I put the negative 5 in front of the 3x and the 2. Alright, that's a tough concept. That looks kind of funny, but we're going to talk about that in class more. That's tough. Alright, now let's just do this now. Just like we did up here, taking away a negative 6 is like adding a positive 6. So taking away negative 10, if I take away negatives, that's doing good things. That's like adding positives to my life. So right now, I'm just going to start getting y'all comfortable. When you see taking away negatives, just making it a positive 10. Alright, I have 4x. Do I have any x's I can deal with? Yep, right there. Okay, 4x plus negative 15x. That's positive. Adding negatives goes this way. So let's subtract those numbers and keep the sign with the 15. So that'll give me 11x, but it's got to be negative. Okay, I have this 12. Do I have any other expressions without an x in it? Yep. Positive 12 plus 10. That's going to give me plus 22. And now we're set. right, let's just look at some terminology, and then you should have enough to be able to do that worksheet. So let's review. What does it mean to simplify? This doesn't have an equal sign in it, so it's definitely an expression. To simplify means to combine like terms. And we're going to talk about what a term is. But we looked at this earlier and said 2x's and 3x's is going to give me 5 of them. So a term are these add-ins of the expression. They're the pieces that are connected with the pluses and the minuses. So there are 3 terms to this expression. Okay? Now the variable terms have the x's. They have that variable in it. So 5x is a variable term and 2x is a variable term. Now they ask for the numerical coefficient of the variable term. The coefficient is the number hanging out in front of the variable. So 5 would be a numerical coefficient, and 2 would be a numerical coefficient. They're the numbers hanging out in front of the variables. They are the numbers that tell you or how many variables you have. Here I have 5 x's and here I have 2 x's. Okay? The constant term has no variable. So the constant term would be the 4 because it doesn't have an x with it. So if a term contains no variable, it's the constant term. Okay? Now, like terms are terms that have the same variable with the same exponent. So the like terms here would be 5x and 2x. So are there any like terms? Yep. Yes, there are. And if so, name them. So 5x and 2x would be like terms. They have exactly the same variable factor, x and x. So to simplify this expression, we're allowed to combine like terms. So I can combine these. If I have 5 x's and 2 x's, that's called 7 of them. Okay? So that's just kind of a review of just some of the terminology that we were talking about while we were doing those problems. And the last piece is just an application. You have a couple like this in your assignment, and I'm going to fill in those numbers for you in a minute. So they would like you to write an algebraic expression for perimeter. Now we remember perimeter means adding up all of the sides. So let's go ahead and write down, since it's a rectangle, what all of the sides would look like. Okay, so we have a 3. We have a 2x plus 5. We have another 3. And we have another 2x plus 5. Okay, my like terms. Well, I have these 2x plus 5. So I have 2 x's here and another 2x. That's going to give me 4 altogether. And then let's go ahead and add our constants. 3 plus 5 is 8. Plus another 3 is 11. Plus another 5. That's going to give us 16. And all of that together is in feet. Now let's talk about area. Now remember, area is just the product of the length times the width. So area would be 3 times 2x plus 5. Now they asked us to simplify it. So let's just distribute and then let's make it look a little easier on the eyes, right? 3 times 2 is 6. We have 6x. And then what's 3 times 5? 15. And now don't forget the labels. Don't forget the units. Square feet. Alright, so that should be enough for you to conquer this worksheet. I'm hoping that you don't have any trouble on it. If you do, give it your best try, and we're going to go over this section again when we come in on Wednesday. Okay? But this is the only question where I didn't give you any labels. So what I'd like you to write down now is the length of this side is going to be 4 feet, and the length of this side is going to be 3x plus 7 feet. And now you know how to do this problem. We just did one just like it to answer area and perimeter. Okay? So this is due at the beginning of class on Wednesday. We're going to go over more like it. Do the best that you can. I think we've covered examples of all of the problems, so you should be able to constantly refer back to the video to look at ones that are very similar to the ones that I gave here for you to work on. So the video should be very helpful in messing around with answering this with some confidence. Okay? Don't forget, bring it in on Wednesday, and we're going to go over it on Wednesday and then answer any questions you might have on it and start section 3.2. Okay? See you then.